Hi, welcome to another session of Circuits and Networks. In today's class 2 under gate exam, we are going to see the problems related to dependent sources for Thevenin's equivalent circuits. Directly we're going to the first problem where in the figure 1, we need to find out the Thevenin's equivalent voltage and Thevenin's impedance as seen across terminal AB. So this is what it is given in the problem. This was asked for gate 2021 for 1 mark. So the options given were A, B, and CDs with 10 volts, 50 volts, 65 volts, and 35 volts in series with respectively 12, 2, 15, and 2 ohms. Okay. So first open circuit voltage we are going to estimate across this terminal AB. When it is open circuited, this 2 ohm becomes dummy in nature. In fact, this is how the circuit would look like. So we have open circuited this as for the given problem, and 2 ohms is neglected. So this exactly the circuit looks like. Now here you can see 5 amperes when it is flowing in 10 ohms, it would be 50 volts. So this can be changed with help of source transformation, assuming 50 volts over here. So that 50 volts I am assuming over here. Okay. Then when we look through terminals AB, applying KVL in anti-clockwise direction, we are going to get. So I have taken this A, B and terminal. I am taking out here open circuit voltage, assuming higher potential to be at top and lower potential at bottom. Now VOC is the unknown voltage what we need to determine, and I'm going to apply KVL in anti-clockwise direction. Why? Because I know this unknown voltage. I know that this is a current dependent voltage source whose current value I1 is flowing in 10 ohms, and that value is nothing but 5 amperes. So this drop is known, and 50 volts, which is nothing but across 10 ohms. So it is easy for us to find out the VOC from figure 1a as minus VOC plus 3I1 plus 50 equal to 0. Applying KVL in anti-clockwise direction. As I told you, I1 is nothing but 5 amperes, right? So substitute uh, 5 amperes over I1. I'm going to get VOC is equal to 65 volts. Let me treat this equation as 3. Okay. Then what you're going to do, apply KVL to the figure 1b. What is this figure 1b? This figure 1b is nothing but we are taking the terminal AB and we are shorting it. Why we are shorting it? Because we need to know the value of the current which is flowing into the through the terminal AB, that is known as the short circuit current. Because impedance is nothing but the open circuit voltage by short circuit current. This is one of the important uh, concept of Thevenin's equivalent networks. So whenever you need to find out the value of impedance, we need to find out the open circuit voltage by short circuit current. When especially source is given, independent source is given, and we have a dependent source problems. So this is one of the method in fact. So we have already found out the open circuit voltage. Let us find out the short circuit current. So for that I am taking the loop currents here as IA and IB. Both are in clockwise directions. This is my assumption. Know that the IB value should be equivalent to ISC. So the short circuit current is nothing but the value of IB. Okay. So keep in your mind that I1, which is the branch current flowing in 10 ohms, is nothing but the combination of IA minus IB when this is shorted. Okay. So applying KVL to this figure 1b, I'm going to get 10 IB minus IA, IB minus IA, because the loop current here it is assumed to be a dominating. Minus on the path, I'm going to get the value of voltage as minus 3I1. So minus 3I1 plus 2IB. 2 it is here. IB is the loop current, that is equal to 0. And what is this I1? I1 is nothing but we know that IA minus IB. Just substitute in this equation, and also know that the value of IA is 5 amperes. So this is the source current 5 amperes, and I loop current, both are assuming into the same direction. That's why IA is equal to 5 amperes. Yes, I'm substituting the value in this equation, and I'm going to get the value of IB, which is nothing but the short circuit current is nothing but 65 by 15 amperes. As I told you, the impedance value can be obtained, or the Thevenin's value can be obtained by open circuit voltage by short circuit current. So open circuit voltage by short circuit current nothing but 65 divided by 65 by 15, it becomes 15 ohms. So in fact, doing the solving this problem, the half itself, we know that the answer is C. But we need to cross check whether we are going to get the 15 ohms or not. This is how the method follows. So it is a very good problem, conceptual problem, and this kind of problems are frequently asked in gate exams. So remember in 2021 we had a problem on Thevenin's equivalent circuit based upon current dependent voltage source. Let us go with the next problem. See, in gate 2015, it was asked for 1 mark. Again, it was a current dependent voltage source, and the terminals were across 2 ohms. We need to find out the Thevenin's voltage. Options were not given, so you don't have any multiple choices. Directly, you need to find out the answer by the concept. So we need to find out the open circuit voltage across AB. To find out the open circuit voltage, that is voltage across AB, consider the figure 2A. So just I am redrawing this figure in this fashion. So open circuit voltage is across 2 ohms. So the 2 ohms here it is placed, and assuming two loop currents as I1 and I2, I'm going to find out the value of loop currents I1 and I2 so that the value of voltage across 2 ohms would be I2 multiplied with 2. That is the voltage across AB. So this is the important catch of this problem. Okay, as soon as you see this kind of problem, you see here loop currents and the branch current I1 and I are on the same directions. That's why here we are taking the value of I1 minus I2 equal to I. This we are treating as equation 1. Then applying KVL to loop 1, I'm taking this one as loop 1 and applying KVL, I'm going to get minus 2 plus 1 I1 plus, again you have 1, I1 minus I2 equal to 0. With this I'm going to get the value of equation by applying KVL to loop 1 as 2 I1 minus I2 equal to 2. Applying KVL to loop 2, okay, so loop 2 had to assume to be a dominating condition, so we will be having 1 I1 minus I2 minus I1 minus 20I plus 2 I2 equal to 0. Substituting equation 1 and equation 3, I'm going to get I1 equal to 23 by 21 I2. See what we have done? Just 20 is kept as it is. I is replaced by I1 minus I2. So that is what we have done. Then we are going to get the terms of I1 in terms of I2 or I2 in terms of I1. So I am here taking the value of I1 in terms of I2 as 23 by 21 I1 I2. Treating as the equation 4 and substituting equation 4 in equation 2, I'm going to get C. 2 I1 is there. So 23 by 21 I2 minus I2 is equal to 2. Now with proper LCM, I'm going to get 46 I2 minus 21 I2 equal to 42. In fact, I2 will be equal to 42 by 25 amperes. Now VOC is nothing but the open circuit voltage. Once we're done with the loop current, the voltage would be I2 multiplied with 2. So this is the open circuit voltage. So this 2 multiplied with 42 becomes 84 by 25. So this is the final answer. In fact, in decimals it is 3.36 volts. So the open circuit voltage across 2 ohms is 3.36 volts. So you have seen this kind of dependent source problems. They are quite time consuming, but that is how the gate questions are framed, such that you need to give some time to solve this kind of problems. So conceptual based problem these are. Now it's a very popular problem. I was asking gate 2012 for 1 mark. The impedance looking into the nodes 1 and 2 in the given circuit is. So I will directly solve the problem because we don't have any independent sources. So we have a common approach that we need to either apply a voltage V and assume that the current I is flowing into the network, and we need to determine the relationship between V and I, or you take the current source and find out the voltage across this node points 1 and 2, and again taking the ratio of V by I, you're going to get the answer for impedance. So how do we do this? So figure 3 is changed to figure 3a like this, and as I told you, I'm assuming a voltage V over here, and that voltage is supplying current I into the circuit like this. Okay, now you see we have V parallel to 100, V also parallel to 9k plus 1k, that is 10k. So the same voltage is supplied across 100 ohms as well as 10 kilo ohms, that you need to keep in your mind. Okay, applying KCL at this node. Which is that node? This is one node. Okay, so this node we are applying KCL. So I'm going to get, see how many branches are there. One branch because of V, that is minus I, because at this node I is incoming. So minus I minus 99 IB, that is also assumed to be as incoming. Then minus IB, you see the IB which is flowing through this 1 kilo ohm, that is minus IB, plus V by 100, that is the outgoing current. So V by 100 equal to 0, because this node is assumed to be at the same potential at this particular node. So both the nodes are at the same point. That's why at a time we had four parameters which is connected to node. This common node, we have four branches in fact. Four parameters, not four branches. So that is how we frame this equation. Now rearrange this equation, we are going to get I plus 100 IB equal to V by 100. Okay. Now what we do, uh, just estimate what is the value of IB. After taking this equation as 1, IB, what is IB? IB, you will observe, it should be nothing but the parallel voltage is nothing but V divided by the total resistance, and I, it is opposition to the this potential V. So IB will be equivalent to minus, because this is the upper plate and the current is shown coming towards it. So IB equal to minus V by 10K, you can represent as 10,000. So this is how the value of IB would be. Frame this equation as 2, and what you do, substitute this equation to an equation 1. So you have I plus 100 IB replaced by minus V by 10,000 equal to V by 100. Now simplify these two zeros and you will be having I minus V by 100 equal to V by 100. In fact, I equal to 2V by 100. In fact, V by I, that is nothing but equal to R, which is equal to 50 ohms. So the only important parameter is to observe the application of KCL at the node, where the node has four branches connected one at a time. By assuming V as the input voltage at this parallel condition, we have solved this particular problem. Node 1 and 2 replaced by the voltage positive V like this. And then taking the ratio of V by I, I'm going to get the value of resistance as 50 ohms. This is one of the important method which we need to follow when independent sources are not given. I hope you like this class. Please share among your friends, subscribe to this channel, and please press the bell icon for the future notifications. Thank you. Bye bye.